This is Ms. Minor, and this is Unit 8. We're skipping ahead, and luckily we get to do something just a little bit different. We get to kind of go in a different direction, take a break from doing slopes and y-intercepts and straight lines. Oh my gosh, we've spent so much time talking about it, but we're going to move in a new direction. And we're going to talk about some exponents today. And this is going to be good times and fun games. Okay, so our target today, what we want to be able to do at the end of this lesson is multiply and divide monomials. That's a new word. So we're going to have to talk about what that means. We're going to get some vocabulary. Let's do that now. Let's move forward. Let's get some vocabulary. Let's do this thing. Okay, here we go. All right. A monomial, what is it? Well, remember back at the very beginning of the year when we were talking about expressions and equations, and we used the word term. And I said when I had an expression that was like 3x plus 4, right? Then this had two terms in it, where this is my term. My first term in my expression. This was my second term in my expression. And anytime I got a sign, that was an indicator that I was moving on to a new term in my expression. Well, once we start dealing with exponents, a monomial is one term. A monomial, then, is one term. And it includes some exponents. Okay, so a monomial is one term, it's just one, and it includes some exponents. Now, here's the thing about monomials, and this is why I kind of have this highlighted up here, this multiplication and division sign up here in the cloud, because one term can have multiplication and division in it. It cannot have addition and subtraction. A monomial has no addition or subtraction in it. Anytime I get to a addition or subtraction sign, that indicates a new term. And so when I have these expressions that have exponents in them, if they have addition and subtraction, they are no longer a monomial. They're what we call binomials or trinomials. And so, or even polynomials. I'll extend the page. I'll add that up there. Polynomial. And this is all like determined by this prefix, right? Here is a monomial. Let's kind of just highlight this for a minute. Monomial, binomial, trinomial, polynomial. See all those weird suffixes? Well, let's kind of try and understand the difference. A monomial is only going to have multiplication or division in it. So I can have lots of things happening. I can have lots of multiplication. I can have lots of division. It could be something like this. 5a squared bc to the third times x to the first y, let's just make something up, to the fifth. And then we can have some division in there. 10 c to the fourth, x to the third. Aha, look at that. And you'll notice there is no addition or subtraction. This whole thing would be a monomial because there's only multiplication and division happening in there. So a monomial, that's what we're going to deal with now in 8th grade. And we are going to only be working with monomials in 8th grade. Monomial means one. That prefix mono means one. Mono means one. So when I start adding in like addition and subtraction, right? That's when I start getting binomials and trinomials. The prefix bi means two. Like bicycle has two wheels. Tri means three. Tricycle has three wheels, right? That's kind of how I think about that. Polynomial, the prefix poly means many. And so polynomials mean lots of addition and subtraction are happening in there. So let's kind of take a look at the examples that are written up here and see if we can decide, is it a monomial? Is it a binomial? Is it a trinomial? And I'm just going to go ahead and put this out here. I don't have any polynomials up on this screen. So we don't have any polynomials up here. That's what you'll deal with a lot when you get into some of your higher grades. 10th grade, 11th grade, 12th grade is when you'll start working with polynomials. In 9th grade, you'll be working with some binomials and maybe some trinomials. So take a look up here. And this is saying binomial. So this would be like two terms in the expression, right? So let's take a look up here. Let's see if we can find the one that has two terms. Remember, anytime I get to a sign, that indicates a new term. So when I'm looking up here, there's my first term, there's my second term. See how that has two terms in it? This is my binomial. Maybe pause the video and see if you can figure out which one is the monomial and which one is the trinomial. Okay, hopefully you realize that here's one term, two terms, three terms. There is my trinomial. And then finally, in this, there is no addition or subtraction. And so that would be another example of a monomial, right? There's only multiplication happening in there. And don't forget, anytime I have these variables in here, anytime there's nothing in between, it's always multiplication. So all of those numbers and letters and exponents that are up there in that monomial, they're all being multiplied. Now I could have some division in there.
Teachers, we have had a few parents call saying they've missed a call from here. If you are calling parents, will you please either let us know or make sure you leave a message so we know where to transfer them. Thank you.
Okay, sorry about that. That's just like you were here in school getting some announcements over the intercom. I apologize for that. Okay, so a monomial can be fairly simple like this, or it could be a little bit more complex like the example I gave you earlier. All right, let's move on. Let's talk about some things when we're dealing with exponents. Here's some more vocabulary. When I have a number out in front, right? When I have a number out in front of a letter, here's my letter, it is always called the coefficient. Oh, and I want to get my arrow now back. The number out in front is the coefficient. When I have a letter, we call it the variable. It is the variable right here. X is the variable. But when it gets an exponent on it, this little tiny number up here is the exponent. We also can call it the power, but it is also the exponent. And it's the little teeny tiny number up on top. And when the variable or when the coefficient or the variable has an exponent on it, it is what we now refer to as the base. So the coefficient will be out in front. It will be the number. But once it gets an exponent on it, it is called the base. And then the exponent, we also refer to it as a power. These two words here are synonyms. They are the same thing. They mean the same thing, exponent or power. And you'll hear me use those interchangeably. A lot of times I'll say x to the fourth power. That means that the exponent is 4. Or if it was x to the third power, the exponent would be 3. So that's kind of what we do. That's how we kind of use those words. And, I could say the variable. I could also say the base. Normally, once it has an exponent onto it, I will refer to it as the base instead of the variable. Okay, so let's just review really quickly what an exponent is and what it does. Okay, so anytime I have an exponent, and I want my arrow back, anytime I have an exponent on a number, let's make this be 4 to the second power, or sometimes we refer to that as 4 squared. Let's add that. Actually, let's do this. Let's go back to here. If my exponent is to the power of 2, sometimes we use that exponent of 2 and we say it is squared. Instead of using the word exponent, if the power is 2, we call this squared. So I would say this is x squared. If the exponent is 3, we use the word cubed. And I say those words a lot. So those are good vocabulary words to know. If my exponent is 3, I say that would be x cubed. And I use that interchangeably a lot with the power of 3 and the power of 2. That's because of area and volume. And you guys have learned about that. A lot of times we're talking about area or volume when we have something squared or cubed. And so in relationship to that, a lot of times we use those words squared and cubed in reference to the exponent of 2 or 3. Okay, so there's some more really good vocabulary words that we need to know. Okay, so now let's go back. Let's talk specifically about what an exponent does. Okay, so if I have 4 squared, 4 to the power of 2, what that's telling me is to take the base and multiply it however many times the exponent says to. So the exponent tells me how many times I'm multiplying the base. And you can write that down. Exponent is how many times I multiply the base. And so I have a lot of students who get tricked because they start thinking exponents mean multiply. But 4 squared is not 8. What is 4 squared? Pause the video, figure it out, and then check your answer later. Okay, I hope you paused the video, and I hope you did this math. 4 squared would be 16, right? Because 4 to the second power is telling me to multiply 4 times 4. What about, now I've got to go back to my arrow. What if I had 4 to the third power then? Maybe pause the video, see if you can figure out what 4 cubed would be. Okay, well, 4 cubed would be 4 times 4 times 4, which would be 64. Is that right? 16 times 4? Yes, 64, right? And so every time I increase in power, this is 4 times bigger, right, than the 64 is 4 times bigger than the power before. I'm actually multiplying it by 4 one more time. And each time my power increases, it's 4 times bigger than the number before it. And that's how an exponent works. So if my exponent is 4, 4 times 4 times 4 times 4. Okay, so we're getting what we say exponentially bigger every time. We can increase things very, very big when we use exponents. We can make our numbers really, really big just by increasing the power on the number. 256 is 4 times bigger than 64. right? And 8 times bigger than 16. So hopefully you can see how that works. Okay. All right. What about if I have a letter? Oh, let's talk about one more thing. What if I just had 4 to the first power? How many 4s am I multiplying, right? Well, if this was 2, right? 4 to the first power is just 4. In fact, anything to the first power is just itself. So if I ever see a plain number that doesn't have an exponent on it, we say it has an invisible exponent of 1. Because anytime I have an exponent of 1, right, what I get is just a plain number. So if I have a plain number and it needs an exponent, and we might in the future need an exponent, I can put an invisible 1 exponent on it. Okay, so again, we have that kind of invisible 1 rule happening here again. Let's talk about if I have a letter then. We've talked about if I have a number. What if I just have a letter with an exponent on it? A variable, if you will. If a variable is my base, it's the same situation. If I have a to the first power, it's just a. If I have a to the second power, it's a times a. And we call this factoring. If I take this exponent and factor it out, we're breaking it apart into how many a's we multiplied together to get that exponent. All right, if I have a to the third and I want to factor it out, it's just a times a times a. If I have a to the fourth, pause the video and see if you can factor a to the fourth. Okay, I hope you said that a to the fourth would be a times a times a times a. And now you can see how a variable works if we factor out the variable and the exponent. And we're going to use factoring to kind of try and help us figure out the rules, because remember, our goal for today is to be able to multiply some exponents together. And maybe divide some exponents. And so we're going to use this idea of factoring in order to help us come up with a rule for multiplying and dividing exponents. All right, so here we go. The first thing that we're going to do here before we move on is we're going to factor out these exponents, these monomials. We're going to factor them all the way out, and so that we can start to see what might the rule be for multiplying and dividing monomials. So we're going to start with multiplying monomials, and this little dot up here means multiply, of course. And whenever I'm multiplying monomials, the very first thing that I want to do is if there's any coefficients. And that means numbers that don't have exponents on them. They cannot have exponents on them. But if I have any plain numbers that don't have any exponents on them, I'm just going to multiply those together first. So here in this monomial, and remember, each of these things is just getting multiplied together. This is r squared times 10 times r to the fourth times 9 times r to the sixth, right? And some of those aren't written in there. Some of those multiplies aren't written in there because we don't have to. We actually don't have to write any of those multiplies in there. But we kind of do that to kind of separate out our monomial just a little bit, especially when we have exponents. But I want to simplify this. And so what's happening here, and I'm kind of going to do this the long way first, and then I'll show you the shortcut version. But the long way of doing this is recognizing that r squared is just r times r, right? And then we're timesing that by 10. And then we're timesing that by 4 more r's. And then I'm timesing that by 9. And I'm timesing it by 6 more r's. And remember, the first thing that we always want to do is just multiply any plain numbers together. Well, I have 2 plain numbers in here. And I can just multiply those together because they're plain numbers. They follow the same rules as any other plain numbers that I multiplied together. 10 times 9 is 90. They're plain numbers. They follow plain number rules. Then I have to figure out how many r's am I multiplying together. Because anytime, let's just take a step back. Remember, anytime I multiply something by itself, I can rewrite it as an exponent. Anytime I multiply an a with an a, it can be rewritten with an exponent. So in all of these, if I'm multiplying all these r's together, really, in order to simplify this, I just want to know how many of these r's did I multiply together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can rewrite it with an exponent. The short version is I don't actually have to factor all of these things out like this to figure out how many r's I have altogether, right? I just have to add the number of exponents together. So the short version is first multiply my numbers. 9 times 10, that gave me the 90. And then add up 2 plus 4 plus 6. So this would be 90 r to the 2 plus 4 plus 6, because each of these is telling me how many r's are there. How many total r's? 2 plus 4 is 6, plus 6 more gives me r to the 12. So the rule for multiplying monomials is find all of the matching bases, all of the letters that are the same, then add up their exponents. If I have more than one letter, then I can't combine different letters together. I can only combine same numbers together. Okay, so let's just practice a little bit and let's see if we can figure out what we're doing. Okay, so this is 7n squared times n to the 5th. Now, I can go ahead and put an invisible 1 in there if that helps me, because what I want to do first is multiply any numbers together. And remember, I can always put an invisible 1 in there if I don't have a coefficient. So 7 times 1 is just 7. And then I'm going to find the matching bases. My matching bases, both of those are matching, n and n. And then I add up the exponents. So n to the 2 plus 5, which gives me 7 n to the 7th. Okay, what I'd like you to do is pause the video, and I'd like you to try the next couple of problems in your practice and see if you can figure out the result. Then come back and check your work. Okay, so I hope you paused the video and practiced multiplying some monomials together. Remember, the first thing I do is I take my numbers. They're just plain numbers, so I multiply those two together. 6 times 7 is 42. Feel free to use your calculator if you need it. Calculators are better at mental math than 8th graders, so that's a proven scientific fact. So use your calculator to help you do the multiplying if you need to. 6 times 7 is 42, and then I'm going to have n to the 2 plus 5. That gives me 42. I better just slide this down a little bit. That'll be for next time, but that equals 42 n to the 7th. And hopefully you got that figured out. Okay, then let's do this next one. This one, I've got 3 different numbers to multiply together. And so I'm going to take those 3 numbers and I just multiply them just like I normally would. And remember, I can multiply however many numbers together that I want to. So 5 times 11 times 8 gives me 440. And then I find all of my like bases, any letter that's the same. N, N, and N. And I just add the exponents. 5 plus 2 plus 5. So I'm going to end up with 440 n to the 12th. Okay, cool. If I had another letter in my multiplication, then I would just combine those letters together. If I can't combine it with anything, then I leave it. I don't do anything to it. All right, so let's take a look at our division. How do I divide? And remember, this is my divide sign. Ms. Minor usually use a fraction bar in order to signify division, right? And so if you see a fraction bar, that just means divide. Now this is where our reducing fractions is going to come into play. And if you are struggling with reducing fractions, you need to watch the video on Canvas about reducing fractions. There's some tips and tricks in there in order to reduce fractions. But whenever I have a fraction, the first thing that I want to do is I want to simplify as much as I can on the numerator, simplify as much as I can on the denominator first. So I always want to simplify first. So if there's anything that I can combine together in the numerator, I'm going to do that first. If there's anything I can combine together in the denominator, I do that first before I move on. So I do all of my simplifying first. So the first step here says highlight the numbers and simplify. So what I like to do is I like to just find my plain numbers, right? 3 divided by 18. That's going to come out of fraction because I have a small number on top and a big number on bottom. Anytime I see something like that, it's going to come out as a fraction. And so I definitely need to reduce this fraction. Now you can use your prime factorization chart, or as long as you're like feeling comfortable, just go ahead and reduce that fraction. So 3/18 reduces to 1/6. So that's going to be my new numerator, my new denominator. Then let's kind of expand this out and see what's happening in order to determine what our rule is going to be, right? So this is a to the 7th. So I have 7 a's, 1, 2, 3, 4, 5, 6, 7. And these are all being multiplied together, right? And then I have 10 b's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh boy. And these are all being multiplied together, right? All of these b's are being multiplied together. And then on the bottom, I have 3 a's, and they're all being multiplied, and then 7 b's. And expanding these out is super tedious. So I want to figure out a shortcut rule, right? But what's happening, I'm just expanding it now to show you what's happening, right? What's going to happen is a divided by a, that's going to go to 1. And every time I have one of these, they're going to cancel each other out, right? They're going to go to 1. And so anytime I have an a on top and an a on bottom, they're going to cancel each other out. And so each of these a's, oh, nope, there's no more a's to cancel out, so I can't cancel that last one out. A, right? They're going to cancel each other out. Anytime I have a b on top and a b on bottom, b on top, b on bottom, b on top, b on bottom, they're going to cancel each other out. And so what I'm going to end up with is whatever's left over. I have all of these A's left over, and I have these B's left over. And so if I count those up, I had 1/6, and then I had A to the 4th, and it ended up on the top in the numerator. Do you see that? A to the 4th, and then 1, 2, 3, 4 B's. B to the 4th on the bottom. Sorry, not on the bottom, on the top. So in expanded form, I can go through and cancel everything out and then just look and see what I have left over. But I don't want to write expanded form every time because that's super tedious and that doesn't make sense, right? Why would I want to do that every time I had an exponent? I don't. I want to come up with a shortcut method. So let's pause the video and let's take a look at these numbers. Here's A to the 4th, B to the 4th. Let's look at what we started with. And let's see if we can figure out what is the rule here. Pause the video and see what you think, see what you notice. Okay, well, what I hope you saw or what you notice is that in division, if I take these exponents and I just subtract them, 7 minus 3, right, I would end up with 4. Oh, look, I'm going to end up with 3 B's. I gave myself an extra B in expanded form. That's probably another reason why I don't want to do expanded form, right? Because 10 minus 7 is going to be 3. And so I'm going to end up with my exponent. Now, how do I know if they're going to end up on top or bottom? Well, if I'm looking at my exponents, see how the bigger numbers were in the numerator? 7 minus 3, but the 7 was up in the numerator. That means my result or my leftover A's are going to end up in the numerator because there was more up in the numerator to start with. So that's where the leftovers are going to end up. And 10 minus 7 is 3, so I was going to have those leftover B's up in the numerator because 10 was bigger than 7. So let's see if we can just kind of go through this and figure out our shortcut method. Okay, so step 1 is highlight the numbers. Let's just kind of start where we started in the beginning. Highlight the numbers or just circle the numbers or box them up or something like that. Highlight those numbers, reduce your fraction. Simplify means reduce the fraction if I need to. I reduce my fraction to be 1/6. Then it says, where are there more variables? Right? In the top or bottom? I'm going to write my letter wherever there were more variables to start with. So since there were more A's on top, my A is going to end up in the numerator. Since there are more B's on top, my B's are going to end up in the numerator. Then the last thing I do is I ask myself, how many more are in the numerator than the denominator, right? And subtract. 7 minus 3 is 4. 10 minus 7 is 3. That's going to be your new exponent. So the quick way is subtract. Okay, so let's kind of go through this one more time and just do our checklist here and see if we can come up with a result. The first thing that I want to do is highlight my numbers and simplify my fraction. Reduce my fraction. 16/28. I know 4 can go into both of those. So that's going to be 4 on top and 7 on the bottom. All I did was take 16 and divide by 4, take 28 and divide by 4. Then I look at my letters. X and Y are what I have here. And X has more in the numerator. X is going to end up in the numerator. Y has more in the denominator, so Y is going to end up in the denominator. Then subtract my exponents. And I usually just always take the bigger number and minus the smaller number because I've already figured out where they're going to end up, right? This one's going to end up in the numerator, the y is going to end up in the denominator. So when I subtract, I'm doing 13 minus 4, and this was going to be 11 minus 7. And so I'm going to end up with 8, and I'm going to end up with 4. And there's my result. So I'm taking my exponents and subtracting. All right, let's try again. Pause the video, see if you can simplify the next two examples. Then come back and check your work. Okay, 20 and 25ths, both of those can be divided by 5. It's going to end up as 4/5. Then I'm going to take a look at my letters. Here's an A. Here's an A. Remember, I can only combine same letters with same letters. The bases have to match up. And so there's more A's in the denominator. So that's where my A is going to end up. And I'm going to have 11 minus 7. And then my B, there is more B's in the numerator. So B is going to end up in the numerator. And it's going to be 3 minus 1. How did I know this was a 1? Well, remember, if I don't have an exponent attached, I can put an invisible 1 exponent in there. There is just one B there, right? And so my exponent is going to be 1 because that's all the B's that I'm multiplying on the bottom. Okay, so now I have that set up. I can simplify again. This is going to be 4b squared over 5a to the 4th. Okay, last one, 30 divided by 30, that's going to cancel and go to 1. What happens? Okay, so now I have 1 over 1, right, or just 1. And then look at my x's. I'm going to end up with x's in the bottom because there's more here in the bottom. And this will be 10 minus 1 because this is a 1x. And then I just have y to the 3rd. What happens if I don't have any other y's? Well, it just stays the same. It doesn't change at all. That y to the 3rd is not going to change at all. And so I'm going to end up with 1 over 1x to the 9th, y to the 3rd. And there's my result. All right. So let's fill in kind of our exponent Bible. Let's figure out today what we did was we did the product rule and the quotient rule. The product rule was if I have x to the a and I'm timesing it by x to the b, I'm going to do x to the a plus b. I'm adding those exponents together. Then we did the quotient rule. Let's do this. Let's make this just a little bit smaller and let's kind of spin this around just a little bit. I'm going to take this and spin it. Yeah, there we go. That's going to make that easier. X to the a plus b. And then my quotient rule, if I have x to the a over x to the b, it's going to become x to the a minus b. I am going to subtract. Now, my rule here is to make sure, is there more in the top or the bottom? Because wherever there are more, that's where I want my letter to be. So that's kind of the key, and that's going to be the place where maybe we get stuck. I see a lot of students make mistakes right there because they're not checking where there's more exponents. Because I want to know if that's going to end up in the numerator or the denominator. Okay, so we have kind of our set rules there. All right. Okay, so let's just practice a little bit with some stuff that looks like I got a lot going on, right? That I want you to know all you're going to do is kind of go down your checklist. And you're going to decide, am I multiplying here or am I dividing here? Which one am I going to do? Okay, first things first, if I have any numbers, well, if I'm looking up here, there's no division, right? And so I just want to take my numbers. I want to highlight my numbers here. Here they are. There's a number. There's a plain number. I'm going to multiply my plain numbers together. Negative times a negative makes a positive. 4 times 2 is 8. Then, the next thing I want to do is I want to find a matching base. Here's an x. Here's an x. I'm going to add their exponents. This will be x to the 4 plus 2. Then I'm going to do the same thing for my other matching bases. Here's a y. Here's a y. So I'm going to have y to the 4 plus 2. And then finally, I'm going to match up. Here's a z. Here's a z. This is going to be z to the 4 plus, how many z's is here if there's not an exponent up here? There's just one, right? So my exponent is going to be z to the first power, or z to the 1 power. Now I can simplify. I'm going to end up with 8, x to the 6th, y to the 6th, z to the 5th. And that's my final answer. That's as combined as I can get it. All right, next one, we're going to divide here, right? Okay, the first thing I want to do is highlight any numbers and simplify my fraction. Well, I only have one number here, right? So that doesn't change. It's going to stay the same. Then I'm going to look, where are there more variables? Top or bottom? So I'm kind of matching up my variables. Here's a p, here's a p. I'm going to match up my variables. I'm going to ask myself, where are there more? There's more in the top. So the p is going to go in the top. This is going to be 4 minus 3. Then I'm going to match up. Here's a q. Here's a q. There's more q's in the top. So q is going to end up in the top. Q to the 4 minus 1. Why? Because there's only one q there. Okay. Then finally, here's an R, here's an R. Where are there more R's? Well, there's more R's in the bottom this time, so R is going to end up down here, 4 minus 2. Now I'm just going to simplify one last time, right? And so I end up with 3 to the p to the first, q to the third, divided by R squared. And that is as simplified as I can make it. I cannot go any farther, so I'm just going to leave it just like a fraction, just like that. Okay, what are the tricky parts? Well, one of the trickiest parts is when I start having numbers that have exponents on them. And here's the difference, right? Before, Ms. Miner said, step 1 should be take those numbers and divide them, right? And so normally what we would do is we'd simplify that, and that would become 1 over 1, right? But that is not the case here, because these are not plain numbers. These numbers have exponents on them. This is 95 to the 21st power. This is 95 to the 18th power. These are no longer plain numbers. These are bases. These just became bases. They have exponents on them now. And the exponent is not 1. It is 21 and 18, right? And so in order to figure out what this is, I'm going to have to use my rules of exponents because now they're bases. So normally I would highlight those numbers and simplify. But in this case, now they are bases, and so they follow the rules of exponents. So what I do is I ask myself, where are there more, top or bottom? There's more in the top. That 95 is going to end up in the top. Then I'm going to ask myself, how many more are in the top? I do 21 minus 18, and I figure it out, right? There's 3 more 95s. This is going to be over 1. because now I've gotten rid of all 18 of those in the bottom. They're gone. So 95 to the 21 minus 18 becomes 95 to the third. Now, the last thing that I want to do is calculate this out. What is this as a number? Once I've simplified it, now I can go ahead and put it in my calculator and do 95 raised to the third power. That's going to be 857,375. That's a big number, right? But if I have a number as my base, I can figure out the exponent pretty easily, and I can use my calculator to help me with the simplified number and write it out as a number. So there's my result. Now, Ms. Minor is not going to mark this wrong, and I'm not going to mark this wrong. So either way that you write it, you can write it as 95 to the third. That is a correct answer. And so is 857,375. Those would both be the same thing because these are equal to each other, right? So they mean the same thing. So you can leave it as an exponent, or you can write it out as a number. What have I got under here? Oh, so here's a key. If I have a number with an exponent on it, I need to skip step 1 and not do it. I'm not going to multiply or divide first if my number has an exponent on it, because it becomes a base. This is now a base instead of a plain number. Okay, so here's a problem from your homework assignment, and you're going to do this practice before you move on to your homework, okay? So let's do this practice. What you should do right now is solve this problem and then check your work, see how you did. If you got it right, you're ready to move on to your homework. If you're still having questions, make sure you're emailing me or Mrs. Zeider, and you're welcome to join us for a Google Meet or come in for an after-school tutoring. Okay, so pause the video, try this one on your own, and use your notes as a reference. Okay, hopefully you paused the video and tried this one on your own. But this one is a little bit, let's say, more challenging, just because I got some monomials down here in the denominator, right? Well, here's the thing. I always want to start out with everything in its most simplified form, right? And so I usually start by simplify this in the numerator if I need to, and then simplify my denominator if I need to. I always simplify first and then go from there. So because there's a lot going on in this denominator, it's telling me it needs to be simplified first. So I'm going to use my rules of multiplication to multiply the monomial and the denominator together and see what I get before I do this division. So I'm simplifying first before I do the division. So my numerator is still going to be 4x to the fourth, y to the third. In my denominator, I'm going to use my rules of multiplication to multiply these two coefficients together first, because they're just plain numbers. They don't have exponents on them. So I'm going to multiply those two together. Then I'm going to combine all of my like bases, x with x, and then this y that's over here, he's just going to stay the same. X to the 4 plus 3, which is going to give me 7. So now I've combined those together. And here, this is what I did. I'm sorry, I don't want to skip steps. I want everybody to be with me and know exactly what I did. I did 4 plus 3, and then I combined those together to get the 7. Okay, so now I've used my rules of multiplication to simplify the denominator. Now I can use my rules of division in order to finish the problem. I'm going to highlight my coefficients out in front. I'm going to reduce the fraction. 4 divided by 4 is just 1 over 1. Then I'm going to combine my like bases. There is an x here. There is an x here. Where are there more x's? In the denominator. And so that's going to be 7 minus 4 in the denominator. Then I'm going to combine my y's. There's a y and there's a y. Where are there more y's? In the numerator. 3 minus 1. And then I can simplify one last time to get 1y squared over 1x to the third. I can actually simplify this even more because I don't really need to write the ones in there, right? I could take the ones out because 1 times y squared is just y squared, and 1 times x to the third is just x to the third. Okay, so there's my most simplified fraction. I would not mark that wrong on a test. And a lot of times it helps us for a little while to put those ones in there. Because if I end up with not having anything on the top or bottom, right, then I need the 1 in there as a placeholder. In this case, though, I ended up with the y squared on top. And so I don't need the placeholder ones. Okay. So there is your result. And sorry, we'll put the ones in there again. Okay. So there is our most simplified. Hopefully you guys got it. Remember to go ahead and email us if you have any questions. All right. Thanks, guys.